Hi, I'm Derek Robinson, a senior technical online course developer here at InterSystems, and today we're going to talk about architecting for success with mirroring in InterSystems IRIS. So when companies use mirroring, you're oftentimes trying to meet your SLAs or service level agreements that you have with your customers. And most of the time, meeting those SLAs is not just being ready for those times of smooth sailing when things are going great and your application is up and running and everything's all good, right? Those aren't the times that are the most challenging. There's also the times when everything goes wrong and there's alerts and there's things that are going down and applications are in trouble. And those are the times when you need to have a very well architected mirroring plan ready among your team and your operations. That's what we're going to talk about today in this video. The thing about mirroring is it's not just something that you can just turn on and be ready to go. You don't just flip a switch. There's a lot that you need to consider and you need to have configurations ready, but you also need to have a plan. And so in this video, we're going to walk through several different items. We're going to walk through some of the key terms and prerequisite knowledge that you need for mirroring. We'll talk about some of the costs and the benefits that you should be considering. Talk about how you can really identify the problem that you're actually solving, not just using mirroring for the sake of using mirroring. And then finally, we'll also consider some of the key considerations, common pitfalls, and most common ways that mirroring can fail. So without getting too far into it in the beginning, let's talk a little bit about what mirroring really is. Well, mirroring, when it comes down to it, is not replicating all of the storage physically in your application. Instead, mirroring is really logically relaying journaled updates to databases that are mirrored. Okay? So when it comes down to it, we're going to actually go over this concept multiple times in this video, but mirroring is only relaying the journaled updates on databases that you are mirroring. And ultimately, when companies use this effectively, you can bring your recovery time down to around 20 seconds in a lot of cases for enterprise customers that are using large mirrored setups. So that's what we're going to go over in this video, and let's get right into architecting for success with mirroring. So let's talk about some of the key terms and prerequisite knowledge that you're going to need for mirroring. So what exactly is mirroring at its core? Like we talked about, it's the replication of journal files, but typically it's between two main systems, a primary and a backup. And we're going to get to the other parts of the system in just a minute. But between the primary and the backup, mirroring essentially is taking those journaled updates and replicating them between those two servers. Now, there's a few different types of mirroring that you can consider. We have synchronous and asynchronous mirroring. With synchronous mirroring, committed changes are made on both the primary and the backup before those changes are confirmed as successful by the system. So what happens with synchronous mirroring is that you're designed here to have zero data loss. But the trade-off there is that you do have some latency because with every transaction or every committed piece of data, both the primary and the backup are confirming that they have had that data written to their system. Conversely, with asynchronous mirroring, changes are queued up and can be shipped later between the primary and the backup. So what this does is it gives you a lot lower latency. You have much better response time because you're not waiting on every single committed transaction to be confirmed on both sides, but you do have the risk of some data loss in this scenario. So we're going to say lower latency here, but at the trade-off of having some data loss. So a little bit later, we're going to talk about this when it comes to the cost and considerations that you need to keep in mind when architecting your mirroring setup. Now, there are a few other terms and roles to keep in mind that may be referenced when you're looking through mirroring materials. The first one is a failover member. You might hear this referred to during conversations about mirroring and planning about mirroring. Ultimately, a failover member is just at any given time which of the primary or backup servers is the backup. So in the event of a failover, the failover member is the system that is going to take over as the primary. Now, you might ask, what makes that decision, or how can those servers know which one of those is the failover member? And that's where the arbiter comes into play. And so back over in this diagram here, we have the primary and the backup, and the arbiter talks to both the primary and the backup, and the arbiter is a referee process that can be able to determine which of those servers should take over as the primary in the event of a failover. So it's a lightweight referee process that does that job for you, and that completes that triangle of a basic mirroring setup that includes these three elements. The last term that we'll talk about is asynchronous or DR or disaster recovery promotion. And if you see this term, this is essentially meaning when you're taking an asynchronous mirror member and you're promoting it to be the system that takes over in the event of a disaster recovery situation. So we're not really going to go into too much specifics about disaster recovery in this video, but those are some of the key terms to know. So one more thing that we should cover before we dive into mirroring is talking a little bit about namespaces and databases. Now, namespaces, as you might know from other InterSystems IRIS materials, are logical layers that sit above your databases, and in a namespace, you could reference multiple different databases as shown here. But remember, mirroring is taking your journaled updates on mirrored databases and replicating them to the backup member, right? And so when you have multiple databases in a namespace, you might have databases that also have namespace mappings out to other namespaces here. So you might have, some global mappings and namespace mappings that, go from this database and actually connect with another namespace. And you need to be aware of what is and isn't being mirrored, right? Things in this namespace that are not in this mirrored database will not be mirrored if you haven't set that up correctly, right? So being aware of the relationship of namespaces and databases is a really key consideration as well. And you need to make sure you do your diligence to know what is and isn't being mirrored, because mirroring is very powerful, but it's only going to mirror what you've configured it to mirror. Now, not every organization uses mirroring for the same thing. And when you're architecting your plan, it's really important to ask yourself, what problems are you actually trying to solve that you see with your business? Are you driven by high availability, where you really want to make sure that all of your critical applications are always up and always running? Are you bound by SLAs that may have strict response time or uptime requirements? Or maybe data integrity is your biggest issue, and you want to really make sure that you have a robust process for ensuring that you never have to roll back to a stale backup and that your data integrity is always top-notch. When determining what your real motives are here, there's a few metrics that are really important for making these decisions, and that's RTO and RPO. So when we talk about RTO, we're referring to Recovery Time Objective. What this is a measure of how long it takes you to get back up to being fully available. That might be 4 hours for some organizations, might be 4 minutes for others, right? But ultimately, the measurement is in how much time it takes you to get back up and running. Now, with RPO, Recovery Point Objective, that measurement also comes in as a unit of time, but you're measuring how much data you can afford to lose. Are you able to afford the last 10 minutes of data be lost? The last 5 minutes of data? Maybe you can afford 0 minutes of data being lost, right? RPO is all about data loss and how much you can afford, whereas RTO is about how much downtime you can afford. Now, when looking at these two metrics and how they relate to InterSystems IRIS mirroring, think about RPO as being with a synchronous mirror setup in InterSystems IRIS, you are designed for an RPO of 0. So with synchronous mirroring, remember that both the backup and the primary confirm that a transaction has been written before confirming success there. So that does add a little bit of latency, but basically leads to 0 data loss. So from an RPO perspective, you're looking at 0 RPO when you have a typical InterSystems IRIS synchronous mirroring setup. So there's the trade-offs there. You have to consider whether uptime and speed, performance, whether it's complete data protection and robustness of your data integrity. All of these are trade-offs that you figure out, how do these metrics play in and what am I trying to achieve? How can I measure success in those areas? So there's a lot of great stuff with mirroring, but it's not free, right? You have to consider the costs that come with architecting and setting up your mirroring plan. So a few of the things that you can consider right away are the obvious physical ones, right? You've got storage, compute, and licenses. And most of the time with all of these, you're pretty much doubling your infrastructure when it comes to setting up a mirrored environment, right? Or more if you're setting up more environments across different disaster recovery zones and things like that. But minimally, you're pretty much doubling your storage, compute, and licenses if you're running a mirrored setup. Then on top of those physical cost considerations, you also have your team and the time that it's taking your team to prepare for these types of things, right? You have to be able to practice your failovers. Make sure you practice constantly, because when it comes down to it and it's time for a failover event to happen, if you've only practiced failing over 1 time or 0 times, you're likely to fail in that scenario, right? So between the different costs of the hardware and everything like that, and also the human element, you need to be able to have people understanding what the setup looks like, knowing how it's going to happen if and when that time comes, and also rehearsing it over and over again. And so if you come away from this section with one key takeaway, it is practice, practice, practice. Make sure that your team is aware of how the failover works so that you don't fail when it comes time to do that. So let's pause for a little reality check. Mirroring does a lot of powerful stuff, but not everything is mirrored, as we've made reference to. So let's talk about some of the things that are not mirrored. First, system databases. System DBs are not mirrored, so you have to be able to account for that. And jumping down lower in the list a little bit, IRIS Temp is also not mirrored as a database. So if you have things that are ending up in IRIS Temp, you're going to want to be able to handle those situations accordingly. Configuration and security settings are also not mirrored. Again, we're only mirroring databases and journaled updates to those databases. So configuration and security, not things that are going to be mirrored by default automatically. You're going to need to come up with a solution for keeping those things intact. Cached queries, right? When a failover happens, the memory buffers are essentially reset on these systems. So cached queries are not going to be something that is mirrored either. And earlier, like we talked about, namespace mappings are not mirrored. So if you have things that are crossing different namespaces and being mapped across those, well, you need to make sure that you're factoring the databases that those source materials are in and make sure that you have mirroring set up on those databases and not relying on namespace mappings as being something to be mirrored, because they will not be with a default mirroring setup. You also should consider some of the common downtime scenarios and how you might account for those, right? So some key things to look out for. One example is, let's say the primary and the backup both go down, right? Now, there's no real way for anything to happen there, and you won't be able to fail over appropriately. So similarly, if the arbiter and the primary go down, the backup may have no way of knowing that it is supposed to become the primary. So if multiple of your instances go down, that is a problem that would cause mirroring to fail, and you'll need to probably look into those a little more closely. Another common point of failure is long-running transactions, right? If a transaction is taking a long time or is an open transaction during the failover, lots of journal work needs to be rolled back, and so that can cause issues with your failover. And lastly, we also have something called configuration drift or misaligned configurations, one of which is configuration drift. So with configuration drift, you're sort of having your configurations over time end up with misalignments, and now all of a sudden the primary and the backup may be out of sync, and that can cause problems. And in some of the worst case scenarios here, it's not exactly configuration drift, but you may end up with a situation called split brain scenario, where both the primary and the backup actually both believe they are the primary. And those can be some of the worst case scenarios that you need to watch out for. So these are common problems to be aware of as you're diagnosing if there is an issue. And during your failovers, you're going to want to be aware that these things can happen. And again, going back to practicing and rehearsing and understanding your systems can help you best remedy those situations should they occur. And lastly, kind of related to all of that, you want to watch out for single points of failure, or SPOF, as you might see it referred to in some shorthand. One example of that is, let's say your entire setup is on one SAN or storage area network. If that network has an issue or goes down, you're going to have a single point of failure where now no matter how good your setup is within that network, if that network is not accessible, not reliable, you're going to have issues and your mirror is not going to be functioning properly. So single points of failure, and this is one example, but anywhere in your architecting of a plan that you find a single point of failure, you want to make sure that you steer clear of those, because mirroring in many ways does a great job of avoiding single points of failure, but they can still occur in various parts of the architecture. So be aware of those and make sure that you're ready to resolve those with different architecting approaches. Success with mirroring really depends on knowing that you're failover ready. One of the first metrics that you can look at for this is IOPS, or making sure that both your backup and your primary are able to keep up with the performance that's required. They both need to keep up with those data writing that's happening when journaled updates are being written, because if the backup fails to keep up with that, then you risk not being able to successfully fail over. Another thing you can do is centralize all of your logging and your metrics into an observability platform so that everything is visible and issues can be brought to the forefront right away. And lastly here, you want to also look at your alerting and make sure that your alerts can be converted to be smart alerts if possible. Now, when the backup takes over in a failover scenario, all of those metrics are going to be way out of whack with what the backup is typically used to, right? It's going to have a lot more traffic hitting it if it becomes the primary. So ideally, your alerts can be smart, understand the context, and not trigger false alarms, or conversely, not trigger appropriate alarms when a system is not actually getting the same type of traffic and metrics and workload that it should be expecting in a given scenario. Now, let's talk for a minute about security and networking. If your mirrored configuration is not on a physically isolated network, then it really should be running over TLS. Now, yes, there is a little bit of a performance cost here, but this is typically worth it for the security that you get by setting up your mirrored environment to be running over TLS. If you're working in the cloud, you also might want to take the added step of encrypting your databases and your journal files to make sure that you have added security in that cloud context. And finally, you want to make sure you're understanding how your clients are going to connect to your applications. Are you going to be using virtual IP? Are you going to be using DNS redirection or maybe load balancers? The key with all of this is resilience. You want to be able to be a resilient application and have a resilient setup, especially with your networking here, because no matter how good your mirrored setup is, if your networking fails, so will your mirror. So wrapping up here, let's look at a few more reasons why mirror configurations might fail, and then look at some key takeaways that we should leave this video with as far as key tenets that you can lean on in architecting for success with mirroring. A few of the common problems that you might see, one is the Linux out-of-memory killer might attack IRIS and end up causing a problem. Network outages, as we talked about, could disrupt the network activity and leave your mirror vulnerable. Hardware failure or VM failure is another reason that could commonly cause mirrored issues. And asynchronous mirror journal storage filling up and causing the disk space to be full is another common reason that you might see that a mirror could fail. The key is not in avoiding these entirely, but being ready for them and understanding why they might happen and how you might resolve them. So make sure you architect all of this into your plan. This is why I like to bring it back to these 5 key tenets of architecting for success with mirroring. The first is understanding. Make sure that your team and you understand what is involved in your mirrored setup and what the different pieces are that are involved in a failover whenever that does need to happen. Planning, and this really revolves around your use case and your SLAs. Make sure that you've planned to solve the problems that you most need to solve to make sure that you meet the SLAs that you're obligated to meet for your clients. Practicing is one of the key components of this whole thing. We mentioned it during the practicing section. Practice, practice, practice. Make sure that you practice failing over. That way, when it is time to fail over, you and your team are very comfortable with the process. You've rehearsed it plenty of times, and you have confidence that it will work as it's supposed to work. Diagnosing, being able to understand how to troubleshoot when things go wrong and diagnose what a problem is. And that leads to the last one, which is monitoring. Knowing what key metrics to look at, such as your IOPS and your system health, and being able to help see that things are in check and proactively know if something is going wrong. So all of these are the key things to keep in mind when architecting your mirroring setup. And by doing these, you can continue to meet your SLAs and keep your business running strong with the power of mirroring in InterSystems IRIS.